Microservices is probably the most popular architectural approach today. It's extremely effective. It's the approach used by many of the most successful companies in the world, particularly the big web companies. As a result, I see lots of organisations and teams attempting to adopt it. Or so they think. In reality, they often miss both the value and the costs of microservices and end up doing something that really isn't microservices at all, and so kind of doing the microservice idea something of a disservice. They don't gain the benefits that they were looking for very often. So what is the problem with microservices? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe and like if you enjoy the content. In this episode, I want to explore the problem with microservices, and particularly why this very valuable architectural idea is probably not quite what you think it is. It's simple, right? Microservices is all about small services, isn't it? No, not really. The first problem is that microservices is a distributed systems architecture, and however you wrap it up, distributed systems are way more complicated than non-distributed systems. There are all sorts of problems that you just automatically buy into when you start distributing computing across multiple different devices. One of the things that microservices are not services with simply a REST API. That's another thing. That's REST. It can be implemented as a microservice or not. REST may be a useful technique in implementing microservices or not. There are many different ways of approaching this, but a RESTful API does not define a microservice. And all services are not microservices. Services as an organising principle for software systems has a very long history. We'll talk a little bit more about that later on. The defining characteristics of microservices are that they are small, as we've already mentioned. They're focused on accomplishing one single task. They're aligned with the bounded context in the problem domain. They are autonomous, independently deployable, and loosely coupled. Let's talk about each of those ideas in a bit more detail. So what does small really mean? Everybody asks this question, and it's kind of an obvious question from the name, right? It's microservices, so what does micro mean? There is an answer that comes from the early pioneers of microservices, which is that a microservice fits inside of James Lewis's head. James was one of the people that first popularized the idea of microservices. He, along with Martin Fowler, wrote the first article that was published, I believe, online, or at least the best known article that describes them in more detail. And James, as you can see from this picture, has a reasonably large head. He's a smart guy, so a fair amount fits in his head. But the idea is to make them understandable, to compartmentalize a problem so that we can deal with it and understand what's going to happen. A reasonable rule of thumb to try and figure out how small is small or how micro is to imagine throwing away your microservice and re-implementing it. How long would that take? If you can do that in a few days or maybe a couple of weeks, it's probably on the right kind of scale. If the idea scares you of throwing away the service and rewriting it from scratch, it's probably too big. The next in the list is focused on a single task and doing it well. This is really about separation of concerns, but at the level of the problem domain. What we're really trying to express here is the idea that a microservice accomplishes one task when viewed from the outside. Now, implementing that task may involve a bit more concerns perhaps. Maybe you're thinking about storage or getting data from another source or something like that. But from the outside, the service is going to be focused on accomplishing one task and achieving that well. The next in the list is aligned with a bounded context. Most teams miss this idea, and it's an important one. A bounded context is an idea that comes from domain-driven design, the fantastic book written by Eric Evans, which describes modeling the problem domain as an approach to designing the software. And one of the things that Eric talks about, one of the key ideas in domain-driven design, is this idea of bounded context. Eric defines it as a defined part of software where particular terms, definitions and rules apply in a consistent way. This is a part of the problem domain where the concepts are related to one another, and so it makes a cohesive unit. This is an important idea in lots of different contexts, but in the sphere of microservices, it's a very important idea because those are the boundaries that we would prefer to align our services with. And this is important for several reasons. First, if we break a problem, a monolithic application, say, into a collection of smaller technical services, that doesn't really qualify as microservices. They are not aligned with the bounded context, and you're going to suffer from increased coupling between those components. Bounded contexts are kind of like natural fire breaks in the problem domain. They are, if we align our software with those fire breaks, then it means that our system is going to naturally be less coupled because the problem domain is less coupled at those points. And so it means that we can write cleaner interfaces to our services and have less chatty interactions between them. One of Eric's pieces of advice in the domain-driven design book is that whenever you transition a bounded context boundary, then you should translate ideas, information that crosses the boundary. That means that every microservice should be translating its inputs and translating to its outputs in order for every interaction. A microservice should always make a break between these points. We should make a significant distinction between the external protocol with which the microservice exchanges information with other parts of the system versus the internal representation of that service and the model within. We need to really treat seriously the difference between the design of those APIs, those entry points into our services, and our consumption of those APIs from other services. If you aren't using ports and adapters in your implementation of microservices, you're probably making a big mistake. We want to always be translating at these points. The next in the list is that microservices are autonomous. The teams that look after these microservices can make progress alone without the need to interact with other services or other teams. I can change the implementation of my service without needing to coordinate with anybody or anything else. This is the biggest value of microservices. This is the thing that allows microservices to work in organizations that scale enormously. But it's also the most commonly missed attribute of microservices. What I see frequently is teams claiming that they're implementing microservices, but building, testing and deploying all of those pieces together. That's something else. Let's explore this idea for a moment of autonomy. Service-based design is not the same thing as microservices. Service-based design has a long history. It's been around for a very long time. If you'll forgive me, I'm a bit lazy and I haven't looked up the history of service-based design, so I'm going to do this from a personal point of view and tell you my interaction with it. I've been building distributed, service-oriented systems, however you want to frame that, for about 30 years now. I started at the end of the 80s and 90s with my first foray into distributed computing. I moved reasonably quickly in the early 90s into ideas like remote procedure calls, and then quickly into an idea of something called object request brokers, where we were simulating interactions with component-based systems in distributed systems. I got involved in a startup where we built some infrastructure to support what we would now think of as quite advanced microservices based on a concept called cooperative business objects, little bundles of domain logic that communicated through what we call a semantic data service, a bit like XML, but predating XML. I then moved on bigger commercial systems, working on component-based systems, message-oriented architectures. Service-oriented architecture came in at the beginnings of this century and became more popular. And then I moved into building high-performance systems based on event-driven architectures, sometimes using patterns like CQRS, microservices, and ending up with something that we called reactive systems. All of these are service-oriented systems. All of these models were based on that concept of little bundles of logic that were somehow more discrete from one another than the classes and functions within our implementation, and so had more abstract interfaces between them. The ideas of service orientation are extremely useful. They're an important idea, I would argue, in computer science and building bigger systems. And I think that they principally matter for two reasons. One of those is technical, the other is organizational. Now, these are very closely related. As Mervyn Conway stated in 1967, any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. So the architecture, the design of our systems, is closely related to the communication topologies that we employ in the organizations that we work in. This has an impact on the kinds of architectures that it's possible for teams to build, and the architecture mirrors your organizational structure. If we decide to divide up our teams on technical boundaries, we have a UI specialist team and a middleware team and a data team, then we're going to build a system that looks a bit like this, a tiered, layered system, and the teams will have to coordinate and interact. More modern software development approaches tend to prefer smaller, more autonomous teams. If we are going to, for a variety of reasons, if we are going to organize ourselves along the lines of more modular, autonomous teams, we're going to build more modular software with more autonomous components, and it looks like this. But this is not necessarily a microservice organized system. We could choose how we were going to organize our teams around this. We could put everything into one big repo and have a distributed service-oriented system communicating with REST or messaging or whatever other technique, or we could have independently deployable units of software, autonomous components that were microservices. They're not the same thing. So, if we can have distributed monoliths organized as collection of services, which is probably my preferred architectural approach, if I'm honest, for many systems, what does microservices add to that? Well, the key thing is that they are independently deployable. Deployability is one aspect of autonomy for these services, but it's an incredibly useful one. If we can work on changes to our service and deploy it without necessarily communicating or interacting with other groups of people, that means that we can make progress without being constrained by those groups. It means that we are developmentally less coupled to the rest of the organization. That's really what independently deployable means. If I need to care about dependencies on other services before I release my change into production, my software is not really independently deployable anymore. Well, this is a big idea, and this is the biggest stumbling block that I see with teams adopting microservices. And the biggest problem, the biggest cost of microservices. This has serious implications for the way in which we design software and the way in which we employ it. You don't get to test your services together before you release. You don't get to force changes that you make to your service on consumers of your service. You can't demand that they update in step with you. That's not part of a microservices model. If our services are autonomous and independently deployable, we build, test and deploy them independently. This is the real value of microservices. This is the step that decouples organizations both technically and culturally and allows them to grow and create software at an enormously fast rate. It's the thing that differentiates organizations like Amazon from more conventionally organized firms. And this is also the real cost, because if you want to be able to independently deploy these services, then you've got to be able to take the ability to maintain that independence really very seriously. Microservices are an organizational decoupling play. That's what they are for. If you don't need to decouple your organization developmentally, they're probably not the right thing to do because they come with this cost. They allow development organizations to grow very big and to work as a large collection of small independent teams. But to achieve this, microservices must be loosely coupled. We need to take that separation of external and internal representation incredibly seriously, and we're going to invest time and effort and development effort into keeping that separation clean. We need to treat the external interface of our services like a public API, because it is. We can't demand that other people change in step with us when we want to make changes to our API. So we've got to be very, very cautious about the ways in which we can change that API. When we're consuming the API from such a service, we should be cautious not to couple ourselves too tightly to it. We should only take the information that is of interest to us and no further. We'd like to make those interfaces as clean and abstract as we can achieve. So we should be very, very, very cautious of breaking changes at any point. It brings in techniques like supporting multiple versions of interfaces on the same service, or multiple versions of services in some approaches. These are the techniques of microservices. This is the cost of microservices, but for that cost you get some huge advantages. We need to create interfaces to our services that we can defend and rarely and only with great caution change. There's lots more to talk about on this topic. We'll certainly explore microservices and modular loose coupled design in future episodes. But if there's anything else that you think would be interesting, please do let me know in the comments. Thank you very much for watching.